Hello everyone, welcome back to our channel. I hope you're all doing fabulously today because today we have got something really special lined up for you. We will be discussing a recent project requirement that landed on our desk, and we'll try to understand the problem statement to figure out the what and whys of the project, and maybe in this journey we may just inspire some brilliant ideas in you as well. So let's not waste any more time and get started with the project requirement discussion. So this is the document containing the project requirement, and we'll be checking this out. We'll first start with the introduction of the project, and here it is stated that the goal of the project is to predict whether an employee is likely to get promoted based on various features such as performance metrics, tenure, education, etc. So these are the features that will be available to us in the form of the data. So we can so this requirement implies that this project particularly deals with employee promotion prediction. So it indicates that we'll be using machine learning and AI to make the prediction to determine whether an employee is eligible for promotion or not based on the features which are provided into the data set. So this prediction, as stated, can help HR departments and managers in identifying high potential employees for promotion, thereby improving employee satisfaction and retention. So this is one of example of real life application of ML and AI. So this was the introduction to the project. Let's see what is mentioned here about the data collection, because that is also one of the very important steps. If the data is the heart of any machine learning algorithm. So here it is mentioned that collect historical data of employees, including features such as performance ratings, education level, years of experience, previous promotions, and any other relevant data points. So basically here it's stating that if you want to build such a system which is able to predict the eligibility of promotion for an employee, so at least you'll need to have these features that are listed in here in the form of your data. And data can be in any format. It can be a CSV file, an Excel file, or even a PDF file if that is available. Then and let's say if you don't have a data set of your own but you want to realize this thing as a proof of concept, then maybe you can go to some open repositories containing data sets. There is this UCI machine learning repository where you can find some data set that corresponds to this requirement, and even on Kaggle you can find some data sets containing such features. It is available there, so you can get it. So after collecting the data, obviously it needs to be cleaned and transformed into a suitable manner for the model. So that is the stage of data pre-processing, and under that section here in the document it is mentioned to clean the data by handling missing values, outliers, and inconsistencies, encode categorical variables if necessary using techniques like one-hot encoding or label encoding. These are the techniques to encode categorical data, and this is very important because machines cannot understand simple English. So if there is some column or features in the data set which are represented in English or any other language, high level language, then it needs to be encoded into a form suitable for the machine learning model so that it can understand what is being indicated by these features in the data. Then there is normalize or scale numerical features to ensure they are on the same scale. This is also one of very crucial steps in data pre-processing because it helps to avoid bias in our models because of the varying ranges of the numerical features which are present in the data. Then we come to feature selection, and here we see that several of the approaches have been mentioned in here. So it says that suppose we have a data set containing various features. So it says that if we have a data set containing various features of employees, such as age, full name, and all those features which are listed in here. We want to select the most relevant features that have the highest impact on predicting employee promotions. So here basically under feature selection, we don't want to use all the features available in the data to make a robust model, and for that we need to adopt some techniques, and few techniques have been mentioned in here. So here it means, like in feature selection, we need to select some of the features from the listed features that stands out from the rest, meaning in terms of the level of information that they are imparting to the machine learning model, or basically will be imparting to the machine learning model. So that can be done by correlation analysis, where we calculate the correlation between each feature and the target variable. And in this case, the target variable would be the promotion status. It's probably going to be a binary variable which is being represented by ones and zero, one indicating that the employee is eligible for promotion and zero being not eligible. So once we calculate the correlation, then features with higher absolute correlation coefficients are considered more relevant, because they indicate strong relationships between between that feature and the target variable. So for example, even an example has been mentioned in here, that if we find that performance rating and number of projects completed have high positive correlations with promotion status, we might prioritize these features for selection. Okay, so basically we should be looking for features which are highly correlated with the target variable, either in positive direction or in negative direction. Okay, then there is another technique using which we can perform feature selection, that is feature importance from tree-based models. So here we train a tree-based model such as random forest or gradient boosting on the data set, and we extract the feature importance scores from the trained model. And features with higher importance again are going to have higher scores and will be considered more influential in predicting promotions. And for instance, again there is an example that if the random forest model assigns higher importance to years of experience and performance rating, then these features are likely significant predictors. So this is how we can select most significant features using tree-based models. And there's another technique, like several techniques have been already listed out here that can be tried out to find a set of significant features, and maybe we can even have a collective voting even based on these techniques, and then find the final set of features. So that is also something that can be adopted. So let's just discuss the third technique, that is recursive feature elimination. So here we'll be using a machine learning algorithm. It can be any algorithm like logistic regression, any classification algorithm to begin with. Okay, so here we'll be recursively removing less important features. Like let's say we start with the whole list of features, then we remove one, then we remove one more, and recursively we'll be removing it, and then maybe at a time we'll remove two and see what is the performance, and we'll create a log of the performance of models using this technique. And then we'll find out, or maybe like after several recursive iterations, we may find out that okay, these are a set of features using which the model was giving good accuracy. Okay, so again we evaluate the performance of the model at each iteration, as I just now explained, and we select the subset of features that yield the best performance. So again, if in one of the runs of the model we find that age, salary and department are less important features, then we may exclude them from the feature set, final feature set. So we come to the Last technique that is listed here for feature selection, that is principal component analysis, PCA in short, and it is generally used for dimensionality reduction. So let's see how it can be used for feature selection as well. So here we apply PCA to reduce the dimensionality of the feature space while training most of the variants. Okay, and we select the principal component that captures the most significant variation in the data, and features represented by the selected principal components are considered for inclusion. And PCA, again for example, may reveal that years of experience and numbers of projects completed contribute most to the variation in the data, making them important features. So this is how we can use PCA for feature selection, but it is still a little bit quite complex as compared to the other three techniques that have been mentioned here, because while performing PCA we lose the name of original features. Like once the data has been converted into principal components, identifying the name of the features becomes very difficult, but again it can be tried out as listed here. Okay, so far we have covered the data collection, data pre-processing and feature selection. This is a general outline of any machine learning project flow. So after feature selection, it's mentioned that the tools we need to build this project basically. So these are some technical requirements after the feature selection steps which have been mentioned in here. Let's check them out. So here we see that the preferred programming language is Python, and it is recommended language due to its popularity and extensive libraries for data science and ease of use. And rightly so, because Python, like for machine learning and AI, the libraries are extensive that are being maintained for Python. And then model and algorithm. So again, classification models are to be used in here, because it's primarily a classification task, classifying employees eligible for promotion and not eligible for promotion. So here they have mentioned to use random forest as the model of choice, as it is a versatile and robust algorithm for classification tasks, known for handling high dimensional data and providing good performance with minimal hyperparameter tuning. So that's also already given in the project requirement, that the model that needs to be built is a random forest model, that is an ensemble model consisting of quite a lot of number of decision trees. Basically it's a tree based model. Then there are some specifics about the libraries also that have been mentioned in here. We see that we can use pandas for manipulating the data frame, and then NumPy is also there for numerical computations, and scikit-learn obviously, which offers a wide range of machine learning algorithms, pre-processing techniques and model evaluation tools, which makes it a go-to library for building classification models, rightly so. And Matplotlib and Seaborn for visualization purpose, to make some plots and represent some insights from the data. Then we come to the graphical user interface. Okay, so in this requirement, not only the model, but again a graphical user interface is also to be created to give an interface to the functionality using tkinter. So tkinter library is a built-in GUI library for Python, which makes it convenient for creating simple and lightweight interfaces without additional dependencies. And even we can create web applications using Flask and Django as well, to and host it on a server so that it can be used for the purpose of making these such predictions. So that's also one way to go about it, but here specifically it has been mentioned that a GUI is to be created using tkinter library. Then we come to model evaluation. So after feature selection, here we discussed some specifics in terms of programming language and libraries, and Again, the model and algorithm has already been defined in here, that is random forest. And once the model has been trained, the next step usually is model evaluation. Okay, so it comes in here at this stage in the document, and it says that to evaluate the trained model's performance using evaluation metrics such as accuracy, precision, recall, F1 score, and ROC AUC curve, that is area under the curve. And these are the metrics that are generally used to evaluate classification models. And so these all are required. So basically for this project we'll be calculating all these metrics and display it. And then it is also asking to tune hyperparameters if necessary, if the model is not performing well, that is, and use techniques like grid search or random search to optimize model performance. Again, if I'm to comment on grid search and random search, grid search is rather more time taking approach, so random search is something that we'll be aiming for first. And then we have model deployment. So again, since we are also giving it an interface using tkinter, it needs to be deployed as well. This is also in the requirement. And once satisfied with the model's performance, deploy it in a production environment. Implement a user-friendly interface for inputting employee data and viewing predictions. Now, in the interface based on this project requirement that we have discussed so far, only those features would be visible on the interface which have been, selected in the feature selection stage, because the model would be trained only on those features. So what I mean to say is that we won't be using the full list of features, or basically we won't be showing it in the interface, because not all of them are needed. So only the features which have been identified as the most significant and important would be displayed on the interface here at the time of deployment. And then basically after deploying, monitor the model's performance over time and retrain as needed. So like over the time, when we get more data set to make the model perform better, it would be retrained. Like that usually comes under the maintenance of the model that has been deployed. And then we have testing and validation stage as well. Test the deployed model with new data to ensure it performs as expected, and validate predictions against actual promotion outcomes to verify accuracy and reliability. So again, these are some of the ways by which it can be verified that the model is performing correctly, to verify it against some ground truth that is already available. And then we have documentation and maintenance. That is also one of the most important things that needs to be maintained with such projects in which they are being deployed. So the entire process needs to be documented, including the data pre-processing steps and feature selection, model training up to deployment for future references, and regularly maintaining and updating the model to adapt to changing business requirements or patterns. So again, documentation and maintenance is also required in this project. And then there is this feedback loop, an additional requirement, that is collect feedback from users and stakeholders to continuously improve the model's performance and usability. So this is the part where human intervention is being asked. That is the model should not solely rely on AI and ML, like using human feedback. It should be fine-tuned. So that's the requirement. Then here there are some bonus tasks as well that can be performed. That is to predict the possible bonus of the eligible employee as well. That is not just predicting the status of eligibility, but also the bonus that needs to be provided. One more thing that can be added is the future employee performance, at least year or annual. Basically, it's saying that, to make forecast of employee performances on an yearly basis. so that beforehand they can have an estimate of the performance of the employee, and then they can track it. Okay. And then interpretability and explainability. The gap here is the need for models that not only make accurate predictions but also provide insights into the factors influencing those predictions. So this is also one of the things that can be added, that is explainability as well. Here, like random forest model obviously cannot do that alone. Maybe it can be like the performance can be enhanced by making use of LLMs here, that can explain the results that are obtained by the model. And then that's pretty much it. This was the project requirement for employee promotion prediction, and I hope you enjoyed exploring the document with me. If you have thoughts, ideas, or just want to say hi, drop a comment below. We'd like to hear from you. And if you are facing a similar challenge or need some creative brainstorming, remember, we are here for you. So don't hesitate to reach out to us to get help to implement such systems. And please do provide your feedback and suggestions. That would mean the world to us. And again, thanks for watching the video. If you enjoyed this video, please give it a thumbs up, and subscribe if you haven't already, and also hit that notification bell so you never miss out on such ideas. And until next time, stay awesome, stay curious, and keep those creative juices flowing. Thank you and have a nice day.